are going to construct this thing. Here we go. We're going to use these numbers. We're going to put them in our calculator. We're not going to put the probability of x in there. We're going to let our calculator actually get that for us, all right? And let's talk real quick, since we got a problem in context, let's talk about what in the world this stuff means, right? What does it mean? It's not bread, it's cake. All right. Oh, you got the bread. Oh, I didn't see it. All right, so what does this mean? What does this mean? This row means this. In Leson spreadsheet, yeah. What does that mean? That means that he made 0 sales for 16 days. Okay? Out of those 100 days that he was on his probationary period, he made 16. He made 0 sales 16 days. This one, he made 1 sale for 19 days, 2 sales 15 days, and so on. Right? So that's how we're going to read this thing. All right. So let's put it in our calculator. So I am going to go ahead and make a new document. I'm going to insert list and spreadsheet number 4. And then I'm going to call this one, let's call it sales. Because if you call it X, there is a column X, and the computer gets confused when you reference it. It's like, hey, well, what do you mean? Column X, or do you mean the variable X? And we'll just avoid that by giving it like a name. So this is our number of sales. I do like calling it X, and actually, the first time I did it, I called it X. But it just created a little confusion. So we have 0 sales, 1 sale, 2 sales, 3 sales, 4 sales, 5 sales, 6 sales, 7 sales. There we go. Additionally, we've got days, right? These are how many days they made each sale. So days. And now we've got to look at our handy dandy list here. Why I keep saying handy dandy. And let's continue to enter that, right? So, if the first one here is 16, we're going to go ahead and put 16 there. All right, so let's go ahead and complete filling in the list using that. Not yet. No, do not put in the third column. Just put in X and F, or sales and... Should look a little something like this. Go up. All right. We're going to go ahead and get the calculator to calculate the probability for us, all right? So we're going to call this prob.
No prob.
Yep. Okay. And now we're going to use this this field, right? Which tells me, hey, it allows me to say that everything in this column is equal to whatever I tell you. Right? It's going to fill in the column for us. So I'm going to say, hey, that's going to be equal to, and we want the probability of each thing occurring, right? We're going to do days divided by 100. And I'm going to put a decimal at the end so that it doesn't give me a fraction. I hit enter and it fills it in for me. It's pretty cool. It's like an Excel spreadsheet. Pretty nifty, right? We're going to do that a lot. It's going to be awesome. And you can see that that matches the values in this table. Huh? By 100. And put a decimal after the 100. Or else it'll give you fractions. And ain't nobody got time for that. Yes. It has been resurrected. All right. So, there we go. We did that. We constructed that. Okay. So now, I do believe. Did it ask for a graph? It did. Construct and graph. Let's go ahead and graph it as well. But luckily, we can use our calculator. It'll do it for us, right? How are we going to do that? We're going to hit dot, insert, and we're going to go data and statistics. So number 7, data and statistics. It's okay if it doesn't look exactly good. Because what you're going to do is you're going to let your x-axis be the variable days. You're going to click. I'm sorry, you want it to be sales. I apologize. Sales. Make it sales. Yeah. Just to make this change? Yeah, I hit doc, insert, data and statistics. Yeah. If any of you are not there, let me know. I'll come get you there, okay? All right. Cool. Now, I want this axis to be the probability of each day of each amount of sales happening, right? So I would like to know the probability that he gets 0 sales, right? That's what I want to graph. I want to graph that I could look at it and say, hey, on day 2, the probability of him getting 2 sales is blah, right? This is how we're going to make that happen. We're going to hit menu, plot properties, and we're going to add a Y summary list, okay? Add Y summary list number 9. And it's going to ask, hey, what do you want this frequency on the side to be? And we're going to choose prob, right? We would like to know the probability that he gets 0 sales, or 6 sales, or whatever, right? And when I choose that as prob, that's what it does, right? So what's the probability of 7 sales? I don't know why that's there. And it'll tell you. And thus, it has been graphed. Okay, next. Whoa. All right, and that's talking about, that is all how to do that on a 84. Well, look at that. Does our graph look like that? Pretty much. Let's see. Looks good, huh? All right. We already. Okay, so let's go ahead and verify that this is a legitimate probability distribution. Okay. How would we do so? Well, first thing, right, we got to look for two things. Are each of our probabilities between 0 and 1? Second thing we got to look for is, do they add up to 1? So, if we scroll down, I do not see any of them that are less than 0 or greater than 1. They're all between 0 and 1. So, condition 1 has been met. Condition 2, do they add up to 1? Well, I could either just add them up, or I could let my calculator do it, right? And then how will we do that? We will insert a calculator page. So we're going to hit dot, insert. Now we're going to put in a calculator page, number 3. The calculator has a function called sum. So if we type in SUM, whenever you're typing and it goes from italicized to regular, that means that you have chosen a function, like a calculator function, something that will make the calculator is predefined as like adding a bunch of stuff, for instance, with sum. So we're going to hit sum. And what do we want to sum? We want to add up all those probabilities, right? We named it prob in this list over here, right? This list over here, right? We named that probability. So what this is going to do is going to add up everything in that column for us. Huh? It adds up to 1. Not name that problem. Yeah, you got to actually put it in. Yeah. Okay. So, it adds to 1. So that satisfies condition number 2, right? All of them add to 1. Fantastic. Woohoo! Moving on. So let's see. Is this a probability distribution? Let's get out our calculator. First of all, are any of these greater than 1? Nope. All right. Well, let's put in our calculator and see if we can add 1. 1, 6. And the next one was 1/4 and 1/16. Oh. One 16th again. It does fractions for us. It's beautiful.
That is great.
Yeah, right? So it adds to 1. And then each probability is between 0 and 1, so yes it is. The answer would be yes. Okay. How about this one? All the probabilities are indeed between 0 and 1, right? And we got to add them up to figure out if it's actually a legit probability distribution. Go ahead and add those up for me real quick. Tell me, does it add to 1? It does. And the answer for this one is yes. Let's try one more. Oh no, let's not. Yes. Actually, what I should do is keep the recording of that and just play it early when I'm done teaching with the class isn't over. Just go ahead and press play and we'll call it good. Right? Because the bell dismisses you, not me, right? You don't get it? Okay, here we go. Alright, so let's talk about the mean of a probability distribution. Okay? This is stuff you got right there. Let's put this thing into action. Hey, we get to find the mean of our probability distribution that we just created using our calculator. Alright, what does this mean, first of all? Oh, what does that mean?
I've seen this before. If she doesn't know. I do know, I just forgot
Well, let's write it out. So we're going to let our calculator do it, right? But the mean is going to be, okay, x times probability of x. Okay, so in our case, we had 0 times, what was the probability of him getting 0? Sales. Probability of 0 sales was, let's get it over here. Come on. There we go. It was 0.19. Plus 1 times, what was the probability of him making 1 sale? Huh? Nobody? 0.15? Thanks. Plus 2 times. You see where these numbers are coming from? Nope.
Yeah, it's coming from the chart. This thing.
Yep. So I went right. So 1 times 0.19. 2 times 0.15 plus 3 times 0.12. Right? 2 times, right? 0.15. Two one. Four times. I'm actually going to erase these. 4 times 0.09, 5 times 0.1. Point 0.01 or 0.1? Dang. 0.1. Plus 6 times. No, I don't know if I made a mistake. It doesn't even catch me. It should be 3 times 0.21, 4 times 0.21. 3 times 0.21, 4 times 0.21, 5 times 0.1. Good? Okay, I did not make a mistake. And then 6 times 0.8 and 6 times 0.8. Times 0.2. All right. Now, we're going to get our calculator to do that. So this is a lot of stuff, right? Before you put it in your calculator, did I make a mistake? Oh. Oh no. It's all skewed. Ooh. Did I at least get it back at 2? Yes, I did. So it's 0.16, 0.19. Got it. So that should be 0.16, 0.19, and we're back, right? That it wasn't catastrophic. But hey, the whole point is, I'm going to show you how to do this with your calculator. You've got a table set up, right?
Right.
So let's go ahead and get our calculator to calculate this for us all in one fell swoop. So, yeah. So what we're gonna do is let's go products. We'll just call it prod because I believe that if we put product, it's not gonna be good because the calculator probably has a function already for product. So what do I want the product, right? So I'm gonna multiply it. So in this column, I'm gonna have x times probability x. So I want sales times probability. Okay. So I'm gonna tell it to fill in this whole column with sales times prob. And there we go. Now multiply them, right? But we need the sum of all those, right? We need to add all those up. But we just did that earlier, right? With our calculator, so we can just say, hey, you, give me the sum. Ooh, look, it's going to be so easy. I can go up here and copy this and just change the B to a D. Then I get 2.6. So what I actually did was, I got that this is equal to 2.6. That is the mean of our probability distribution. All right, what does that mean? 2.6. Another way that we express that, it's also called the mean of a probability distribution is also called an expected value. All right, which makes a lot of sense, right? That means on average, right? On an average day, how many sales would you expect this guy to make based on his 100 days of sale? 2.6. That's what that says, right? So the mean of this probability distribution is telling you how many sales on an average day you expect this guy to make. 2.6. That might be low, unless he's selling cars. If he's selling cars, then he's killing me. Oh, so you're gonna put? I'll show you. Oh, let's continue on our journey. We already did that. Now let's talk about the standard deviation. So our next task is going to be to calculate the standard deviation of our probability distribution by first, calculating the variance and then the square root of the variance, which is of course our standard deviation. So this is important stuff to write down. All right, so let's go ahead and calculate the variance and standard deviation of that probability distribution that we've been working on in our calculators. So let's look at, whoa there, Tiger. Whoa, Blossom. Okay. What does this formula mean? Our formula for variance says that our standard deviation squared is equal to the sum of all x minus my mean squared times the probability of x. Cool? That means that, so we'll just fill in the first one, right? That says that we'll have 0, right? With the 0 sales, right? Minus the mean sales squared times, what was the probability of 0 sales? It was 0.16. Really sure? 0.16. Well, that's 1. I don't know why no, I just 0.16. 0.16. And you're going to do this for all 7 of them, right? There's going to be plus the other one. So you can see that can be very long, right? A lot of writing, a lot of stuff to put down. We're going to have our calculator do it for us. So let's call this SD for standard deviation. Although this is not our standard deviation, but it's going to help us get our standard deviation. So we're going to put equals. In this case, X was sales, right? So in parentheses, we're going to put sales minus our mean, which we determined was 2.6, right? In the last exercise. Okay, we're going to close our parentheses. We're going to square it. And then we're going to multiply it times prob, right? That's what probability of X is. All of these here in this prob column are our probability, so we're going to call it prob. When we hit enter, then it fills those values in. Prob. Right? And what is that doing? It is multiplying 0 0 minus 2.6 squared, and then it's multiplying it times that value right there. All right? So now, in order to calculate our variance, right, we need the sum of all these things, right? So we need to add up everything in the column. So we're going to get out our calculator, and we're going to use that sum function again. But now we're going to sum everything in the column SD. And that is our variance, 3.72. What then is our standard deviation? If the variance is 3.72, how do I get the standard deviation? What are you going to do? It is squared, so then you are going to, you said it. Yeah, you're going to take the square root. Do you like pina coladas? Dang it. So in order to get, sorry, I was about to throw. In order to get the standard deviation, that is going to be the square root of the variance, which is 3.72, 1.93.
You use that to like solve off the column, right?
Huh?
Like the last column that you used.
Yes. You're asking which column did I use? SD?
Yeah.
Yeah, so I summed everything in this column SD, and then took the square root, and that gave me my standard deviation. Good job, guys. So, hey, there's their version of that. We made that same thing, but we used technology. It was much easier that way. And then, if you were interested, this is how to do this using a TI-84. And I am sorry, I think that we... Alright, so when we come back, we will do it one more time. Do a little practice with it, alright? Fantastic.